Assalamu alaikum and welcome to the Mathcast with Faria Yusuf. And the topic here is geometric progression. A geometric progression is a sequence that has a common ratio between each term. Common ratio between each term, and what is the common ratio? Common ratio is equal to common ratio R, it's represented as R, and this is actually the ratio between the two consecutive terms, so that we can say it's T2 divided by T1 or T3 divided by T2 or T4 divided by 3E, so on, so that it's the ratio between the last term and the term before the last term. So this common ratio, it has to be a constant value for the geometric progression. Example, if a series is given as 3, 6, 12, and 24, if this is the sequence that you have, 3, 6, 12, 24, then I can see that my common ratio has to be T2 by T1, which is 6 divided by 3, T3 by T2, which is 12 divided by 6, or T4 by T3, which is 24 divided by 12. For all the ratios that I have, I can see that 6 divided by 3 is a 2, 12 divided by 6 is also a 2, and 24 divided by 12 is also a 2. Therefore, the common ratio here shall be equal to a 2. Let's do another example. Sequence that we have now is for 2, -6, 18, and -54. Therefore, the common ratio should be equal to -6 divided by 2, or 18 divided by -6, or -54 divided by 18. So for all the three ratios that we have, we can see that the common ratio is coming out to be a -3. -6 divided by 2, -3, 18 divided by -6, again it's a -3, and -54 divided by 18, that is also a -3. The common ratio here is going to be a -3 then. A geometric progression with n terms can be written as, so this geometric progression with respect to the first term, which is a, and the common ratio, we can say that the sequence here for geometric progression can be given as ar, ar square, ar cube, so on till ar to the power n minus 1. Therefore, we can have the nth term of a geometric progression, which can be written as Tn, the nth term, equals ar to the power n minus 1. A is the first term, r is the common ratio, and n is the nth term here. So if I write these values, I can say a is the first term. It has to be the first term. R is the common ratio, and we have n, which is the nth value here. So Tn shall be equal to ar to the power n minus 1. Again, we can see here that if this is, let's say, if this is the fifth term, then I can see here that r shall be having the power for 5 minus 1, which is equals to 4, just 1 less than 4. So T5 then will be equal to ar to power 4 here. So example, if this is T7, then this should be equal to ar to power 6. If this is the 18th term, T18, then we can say this is ar to the power 17. So this is how we shall be having our geometric terms here. Let's do a question. The nth term of a geometric progression, we are talking about the nth term of a geometric progression, GP, and this nth term is given as 10 into 1 by 2 to the power n minus 1. So find the first term and the common ratio. Now we can see here that the formula that we have at the moment is basically Tn, the nth term, which is equals to 10 1 by 2 to the power n minus 1. So if we look at this formula, if we look at the term equation that is given to us, we can see that it is Tn, which is equals to 10 into 1 by 2 to the power n minus 1. I can just compare it with the term formula, and I can see that this a value is basically a 10. My common ratio here is a 1 by 2 to the power n minus 1. So if they are asking for the first term and the common ratio, then I can just compare and say that my a equals 10, or I can say for the first value my n is equals to 1, therefore Tn is equals to 10 into 1 by 2 to the power 1 minus 1, which equals a 0, 1 minus 1, which is equals to 0. So any number to power 0 equals a 1. Therefore, the first term here, therefore, it's the first term here, which shall be equal to T1, which is equals to A, and this equals a 10. Or I can just compare and see that this is coming out to be a 1 by 2, or I can be getting my second term by substituting n as 2, and I can see it's equal to T2, which shall be equal to 10 into 1 by 2 to the power 2 minus 1, which is a 1. In other words, I can say this is 10 into a 1 by 2, and I can say that this T2 is equals to a 5. So if this T2 is equals to 5, then I know that my common ratio is equal to T2 by T1. I have both the terms. T2 is 5 and T1 is a 10. So I can say that my common ratio comes out to be a 1 by 2. So we could have done this by comparison, or we could have done this by substituting the n values as 1 and 2 and then getting the common ratio, which is equal to 1 by 2 here. The sum of a geometric progression can be written as Sn equals a times 1 minus r to the power n divided by 1 minus r, where we know very well that a is the first term, r is the common ratio, and n is the nth term. And here my r should not be equal to 1, because in that case it's 1 minus 1 becoming a 0, and any number divided by 0, any number divided by 0 is an undefined number. So r should not be equal to 1. Now we use this formula when your r is between -1 and 1. It's -1 less than r, which is less than 1. So when we do not have r within -1 and 1, then we use the formula Sn equals a times r to the power n minus 1 divided by r minus 1. So this is again the case where r has to be greater than 1 or r has to be less than -1 here. So let's do a question. The third term of a geometric progression is 16. Let's start underlining the keywords. We are talking about the third term of a geometric progression, which is 16, and the sixth term is -128. So find the first term, which is a, and the sum of the first 7 terms. So n equals 7 here. So let's start working on it. They are saying it's the third term of the geometric progression. We know that the nth formula, term formula for geometric progression is a r to the power n minus 1. They are talking about the third term, meaning I should say that this is equals to a r n square. So the third term of this sequence is a 16. So I can very well say that this is 16, which is equals to a r square. And the sixth term. So let's go to the sixth term now. So the sixth term here, it's T6, which shall be equal to a r to the power 5. And the sixth term is -128. So it's -128, which is equals to a r to the power 5 here. Now we are supposed to find the first term and the sum of the first terms. Yeah. So going back to the first equation that I have, 16 is equals to AR square. From here I can say it is A, which is equals to 16 over R square. And from the second equation that I have, it's negative 128, which is equals to AR to the power 5. From here, I can say that it is my A, which shall be equal to negative 128 divided by R to the power 5. I can just solve the two equations simultaneously. And when I do that, I will be getting 16 over R square, which shall be equal to negative 128 divided by R to the power 5. So r square and r to the power 5, that can be resolved to r cube, or I can say it's r cube, which is equals to negative 128 divided by 16. So negative 128 divided by 16, that gives me the answer as negative 8. R cube equals negative 8. Therefore, I can say that my R shall be equal to a negative 2 here. So my R, it comes out to be a negative 2. So if I have my R, which is a negative 2, then substituting this R in any of the two equations for A, I can say that my A then shall be equal to shall be equal to 16 over r square, or this is 16 over negative 2 the whole square, or I can say is 16 divided by 4, which shall give me the A value, which comes out to be a 4. So I have my A value, which is equal to a 4, and this was something which was asked in the question. So my A, it comes out to be a 4 here. The next thing that the question is asking is the sum of the first 7 terms. So the sum of the first 7 terms, so I can see that my r is less than negative 2. So I will use the formula for Sn, which is equals to a times r to the power n minus 1 divided by r minus 1 here. So if I use this formula, S for 7 terms, so S for 7 terms, I'll be using n as 7, A is a 4, R value is a negative 2 to the power 7 and a negative 1 divided by negative 2 and a negative 1. So here my answer is going to be negative 2 to the power 7. That will give me 128, negative 128 and a negative 1 divided by negative 3. Or I can say S7 shall be equal to 4 times negative 129 divided by negative 3. Solving it, it's 43 here. So my sum for the 7 terms comes out to be 4 times 43. Or I can say my sum for 7 terms equals 172 here. So this is going to be the answer for this question. So let's do another question. An arithmetic progression has first term A and a common difference D. It's an AP with first term A, and there is the common difference which we have as a D. The first, third, and the 13th term of the AP, the first, third, and the 13th term of this arithmetic progression form the first 3 terms of the geometric progression with common ratio r. So that means it's in AP, it should be, if I compare my AP, then they are talking about the first term, which is T1, the third term, and then it's the 13th term here. So the first term can be written as A, and the third term can be written as A plus 2D, and the 13th term for the arithmetic progression can be written as A plus 12D. So these three terms, they can form the first three terms of a geometric progression. So three terms of a geometric progression, meaning for geometric progression, the first three terms shall be a, ar, and then it should be ar squared. So these three terms, they are forming the first three terms in the geometric progression here. So express d in terms of a and find the value of r then. So expressing d in terms of a, what I can say here is that I can compare a plus 2d. And say if I compare the third term of the AP to the second term of GP, I can say it's a plus 2d, which is equals to ar. Or I can say that this should be equal to r. This should be equal to 2d, which is equals to ar minus a, or I can say that my d shall be equal to a by 2 and r minus 1 here. And if I compare the 13th term of my arithmetic progression to the third term of my GP, then here I can say that it is a plus 12d, which shall be equal to ar square. Or I can also say that it is 12d, which is equals to ar square minus a. Or I can say that it is the common difference d, which shall be equal to a times r square minus 1 divided by 12. So I have d in terms of a as well as in terms of r. Now I need to have the value of r. So to do that, I'll be equating both the equations for the common difference, and I can say that this is basically a by 2 times r minus 1, which shall be equal to a by 12 times r square minus 1 here. So I can see that a is getting simplified, 2 and 12 also getting simplified by 6. So this becomes 6 times r minus 1, which is equals to r square minus 1. Or I can say that this is 6r minus 6 minus r square and a positive 1, which should be equal to 0. Solving further, I can say it's a negative r square plus 6r and a negative 5, which is equals to 0, or r square minus 6r and a positive 5. This comes out to be 0. So factorizing the two equations, I should be getting the r value as, after factorization, this will be solved as r square minus r minus 5r plus 5 equals 0. R taken common, it's r minus 1 minus 5 bracket r minus 1, which equals 0, or r minus 1 bracket r minus 5, which equals 0. Therefore, r equals 1 and r equals 5. Now here I know that my r cannot be equal to a 1, so the value of r that I should be having here should be r equals 5. So this was the first part, part A. The second part says the fourth term in the geometric progression also appears in the arithmetic progression. Determine which term it is. The fourth term in the geometric progression appearing in the arithmetic progression. So first let's find out the fourth term in this arithmetic progression, in this geometric progression. So for part B, the fourth term in the geometric progression should then be equal to T4, which is equals to AR cube. Or I can say that it is the fourth term, which shall be equal to A 5 to the power cube, or it is 125 and A here. So this is the nth term in the geometry, in the arithmetic progression. In the arithmetic progression, I can say that the general formula, nth term formula in this arithmetic progression is Tn, which equals a plus n minus 1 times t. So Tn here shall be 125a, which appears somewhere in this in this arithmetic progression. So I will be substituting Tn with 125a, which equals a plus n minus 1 and d. How else can I write d here? I should say that my d from the initial working for part A, I got my d value here as d equals a by 2 and r minus 1. So I can substitute this value a by 2 r minus 1 over here. So it's a by 2 bracket r minus 1. I have the value of r, which is a 5. I can substitute that value here. So this is basically 125 minus a. This a is taken, this a is taken now on the left. So here I will be left with a by 2 and n minus 1 and r minus 1. R is a 5, therefore I can say it's a 5 minus 1 giving me a 4. So it's 2 and 4 getting simplified, giving me a 2a. So 124 here, 124a, which shall be equal to 2a and n minus 1. So I can very well say now that n minus 1 can be equal to 124a divided by 2a. The a gets simplified, or n minus 1 shall be equal to a 62 and n here is equals to 63, meaning it's going to be the 63rd term in the arithmetic progression, which can be the fourth term in my geometric progression. So the fourth term in the geometric progression is the 63rd term in the arithmetic progression here. Let's move to the next question. Three consecutive terms of a geometric progression are x minus 1, x squared minus 1, and x plus 1. Find the two possible values of x. So we have three consecutive terms here, x minus 1, then we have x squared minus 1, and we have x plus 1. Let's say that these three consecutive terms are t1, t2, and it's t3. We have to have the two values of x to get the values of x. I know that in geometric progression it's the common ratio, which should be equal to t2 over t1, and this should be equal to t3 over t2. I have the three consecutive terms. I can substitute their values and I can say this is x squared minus 1 divided by x minus 1, which can be written as x plus 1 over x squared minus 1. Solving them further, x squared minus 1 can be written as x minus 1 and x plus 1 divided by x minus 1. And this can be equal to x plus 1 divided by, again, x minus 1 and x plus 1. So I've just applied the identity which says that it is a square minus b square, which can be written as a minus b and a plus b. So x minus 1 gets simplified, x plus 1 here also gets simplified. I am left here with x plus 1, which is equals to 1 over x minus 1. So x plus 1 and x minus 1, again this is a plus b and a minus b. I can say this equals x squared minus 1, which equals 1, or x squared, which is equals to 2. So if x squared equals 2, I can take the square root on both the sides, which can give me the answer as a plus minus under root 2 here. So the two possible values of x that I can have here are x equals plus minus under root 2.